Hello, in this video I want to teach you about magnetism. We're going to focus on the magnetism part of electromagnetism right now. So let me talk about magnetic fields and field lines. This is a permanent magnet. Maybe you've played with it. It's like a bar of iron and it has a south pole and a north pole. It can be magnetic even when there's no electricity moving through it, and this is one of the major kinds of magnets that exist. We also have electromagnets, which are normal wires just wrapped around in loops. They require electricity to turn on, but that's what they use in the big magnetic cranes at a dumpster, where they go down and they grab a car and they drop it into a mulcher. Those are electromagnets because you can turn them on and off. What do these permanent and electromagnets have in common? Well, they all interact with a magnetic field. The magnetic field is a lot like the electric field. Remember where every single point in space got a three-dimensional vector? It's the same, except it has a magnetic field vector instead of an electric field vector. So maybe this is the picture of a magnetic field in a box. In the real world it's 3D, but we're not going to worry about the real world. We're going to simplify and make everything 2D. So we're going to pretend like we have 2D arrows pointing in some direction everywhere in the universe. These are some examples of magnetic field lines produced by a horseshoe magnet on the left, a bar magnet in the middle, and an electromagnet on the right. You can see them if you take a magnet and you scatter some metal filings next to it. You'll really physically see these patterns be drawn out. You can see these loops and arcs when the iron aligns with the magnetic field. So magnetic fields, what makes them different than electric fields is they always form loops, never straight lines, always little circles. So these magnetic field lines that we draw, they basically tell you the direction that a compass would point if you dropped it. A compass needle is just a tiny magnet, so it makes sense that we would use them to visualize the magnetic field. Every single magnet in the world has two poles. They have a north pole and a south pole. The north pole is where the field arrows come out. Notice that all the arrows near the north pole, they're pointing outwards. And the south pole is where all the arrows enter in. Notice down here, all the arrows are pointing inwards. So the north pole and the south pole are kind of like positive charges and negative charges, but they always come in groups. They don't come alone. There's no such thing as a magnet with just a north pole. If you actually took a magnet and you cut it in half, the halves of the magnet would spontaneously create new north poles and south poles. You never have just a north pole, and you never have just a south pole. They always come in pairs. Now, magnets are kind of like electrical charges in the sense that opposite poles attract. You probably have noticed this if you played with magnets before. A north pole and a south pole, they're going to attract each other and stick together. Now, they're also sort of like electrical charges in the case that similar poles repel. So, the north pole and the south pole, they stick. But if you have the north pole and the north pole, and you put them next to each other, you're going to push away from each other. So the north pole of one magnet will repel the north pole of another one, and you'll feel a push. So those are some of the basics of magnetism. All magnets come with a north pole and a south pole. The magnetic lines form loops, with the arrows exiting out of the north pole and entering into the south pole. Now I want to teach you about some basic uses of magnetism. So remember when I talked about light as an electromagnetic field, and I said that the electric fields create the magnetic fields, and the magnetic fields create the electric fields? This happens. When a magnetic field changes values, when the arrow changes, you create an electric field that goes along with it as well. So that means that if you take a magnet and you move it around a wire, you're going to create a current. You're going to create electricity. This current, when you take a magnet and all you do is you just spin it around or move it around next to a wire, it will create electricity that you can use. So these right here, where I have a magnet spinning around some wire, these generate electricity. This is what a generator is. If you've ever seen a hydroelectric dam, like the Hoover Dam, there's a bunch of water going down a waterfall. All that water does is it spins magnets. That's all it does. Water goes down and it spins a magnet. And what that does is it creates electricity in the wires next to the magnet. And then that electricity is piped out into the houses of people who need to turn on their ovens or turn on their lights. We also use magnets to make electric motors. So when you have an electromagnet, which is a magnet where you power it with electricity, basically, you can change the direction of the magnetic poles on command. So you have a north pole and a south pole, and you flip it. The south pole becomes the north pole becomes the south pole. When you can control this flipping, you can cause things to spin or rumble. So you can cause the magnet to flip over and over again, causing it to alternate and spin. It's like a reverse generator. So in a generator, we use spinning magnets to create electricity. In a motor, we use electricity to create spinning magnets. It's how the ceiling fans work in your house. You turn on the switch, electricity goes into the electromagnets in the fan, and then that causes them to spin. So magnetism is literally everywhere. TVs, toasters, credit cards, these all use magnetism. Also, everything that uses light, like light bulbs or your eyes when they detect visual images, they use magnetism. Everything that is electric also generates magnetic fields, which is either helpful or it has to be dealt with. For example, your brain, when you have nerves that fire off electrical impulses, they create magnetic fields around your head. So you are creating a bunch of magnetic fields when you think. That was it. It's pretty simple, but this is an introduction. I hope it was helpful.